Okay, so welcome everybody to the first working group presentation. My name is Hanna Lindberg. I have moderated this working group these last days together with Mirta Medenak, and we are today very happy to present what we have been working on, so what our delegates have worked on. We have 4 delegates, so we'll present from different subgroups. And they have focused on, so the working group is called Space for the Blue Planet, so space for our planet. And it's focused on maritime coastal areas and how you can use space technology to have a more sustainable future. The different subgroups are focusing on maritime traffic and to raise awareness relating to climate change. And last, a framework to prevent illegal activities. And starting with the maritime traffic, I leave the floor to Malise. Have a more sustainable future. The different subgroups are focusing on.
So hello everyone, I will be presenting the first part of the working group 1, Space for the Blue Planet we explored, which is maritime traffic, and especially for commercial ships and vessels. Next slide, please. I can't see it yet. I can't hear you, Hannah. Oh, sorry. Yes, perfect. Thank you. So I hope you all had a good meal because this is a technically heavy presentation. I will try to summarize every point. So our problematic here is how can we use space technology to optimize and create sustainable commercial shipping? So the keywords we try to explore are, in general, shipments, logistics, economic benefits, minimization of pollution, and commercial routes. So we explored this in 4 different topics. The first one being awareness at sea. The second one, monitoring and reducing marine pollution. The third one, optimization of maritime logistics. And the last one, maritime traffic in the Arctic region. Next slide, please. So for the awareness at sea, so when we talk about awareness at sea, we want to make sure that all ships and vessels are visible, or at least we know where they are localized at all times. And also we want to be able to do rescue activities in outer sea and to do it quickly. So one of the main some of the main challenges, I will not do the whole list, but some we could highlight are, for example, the need to differentiate between civil traffic and potential threats. Another one would be also to have a higher availability of help and rescue at sea, especially in remote regions. So to answer these challenges, an idea would be to use machine learning for faster data processing and pattern recognition. So, for example, to differentiate between a civilian commercial ship and a threat like piracy. And for the availability of help and rescue, so there is for now for example the COSPAS SARSAT program that exists, and it consists in satellite signals receiving data from receivers at sea for ships in danger, and providing quick help and rescue teams. But these receivers are not generalized, and not every ship or vessel possesses one of those receivers. So the idea would be to globalize this program to all ships and vessels, at least in the commercial field. Next slide, please. So the second topic we try to focus on as well is the monitoring and reducing of marine pollution. So there are different sources of marine pollution. Some are of direct origin and some of indirect origin. So when we talk about direct origin, we think about land-based pollution, the lack of awareness on human activities and their impact on pollution, and also ocean-based activities such as oil spills, seabed mining, and ballast water. So ballast waters are the dirty, polluted waters that ships carry around from one port to another, and they can truly affect and cause damage to marine biodiversity along the way, and also in the port of arrival, because it can change a whole ecosystem. So in this image, you have the examples of those sources. Yes, next slide, please. So some solutions to address these challenges, the challenge of marine pollution, would be, first of all, to provide more accurate imagery, temporal and spatial capability from Earth observation sensors. So, for example, we will want to be able to see smaller debris or pollutants at sea, and to be able to do that, we need a better resolution. From the spatial point of view. So we have an example of oceanography mission on the right with Sentinel-6. Also, there could be the tracking and monitoring stations implemented in different areas to analyze water temperature and the pollutants in those regions, in those ports, for example. And the last solution to address the marine pollution issue would be to work on Earth observation tool for the general public and to sensitize people about it. And this will be discussed later on with Aman. So now the third topic we address also in the maritime traffic, what is the optimization of maritime logistics. So there are many solutions that already exist and that could be improved. One I would like to highlight is, for example, the development and implementation of auxiliary marker stations, so laboratories placed at different spots to identify the weather hazards in those regions, or the currents, the surface, the winds, and to know exactly what could be optimized if ships or vessel go through that specific routes. So and of course the use of general navigation data can be improved. Next slide, please. And the last point is maritime traffic in the Arctic. So we discussed it a little bit with ISA in our working group. The Arctic region represents even more interesting commercial assets nowadays because the ice coverage is diminishing. So in fact the Northern Sea route, which goes along the coast of Siberia and Norway, actually can help sometimes cargo ships save at least 10 days of sailing between Europe and Asia. So it has a tremendous commercial impacts, as you can see also on the image. And but the main challenges still exist, and they are that it is still a hostile environment, even though the ice coverage is diminishing. So intense cold and heavy fog in the summer. Also, there is a lack of consistently updated mapping data in these regions, and an active ionosphere which affects satellite communications. So some existing solutions are, for example, the IceCast project, held in collaboration with ESA and Finnish institutions. So this project actually develops a decision-making tool to help ships and vessels, especially in those regions, have regularly updated weather forecasts and also on ice coverage, for example, and to be able to trace the best optimal routes from one point to another. But there are still ideas to be explored and things can be improved. So, for example, we need to mobilize local actors to work with ESA and to have regular updates on gravity fields on the region and 3D mapping. So we could do the first one using quantum technology, as we discussed earlier in the ESGW. Also support multi-constellation receivers and to be developed and tested for navigation purposes. And another point would be to make automated identification system mandatory for all ships to be able to track them at all times and help them in this region. Thank you. You're on mute, Hannah.
Thank you. Thank you so much, Malise. It was great and perfect timing. So I leave directly to the next group, and also to inform, please ask questions. We will take them all at the end. So you can write them in the question and answer column. Thank you. So for the next group is Aman Crowd.
Hi, I hope I'm audible. So, hi everyone. I'll continue where Melis left off, as in the wonderful presentation she gave. Now we come to the topic of raising awareness on climate change and how do we take action on it. So we basically work together to figure out a solution to it. So I think we all are aware of the problem and the scale that it possesses. Climate change is on the rise. Then there are multiple issues in economic and other fronts, like the maritime issues and sea pollution, and it's a lot. Like, I mean, we're all aware of it. Then we are somewhat directly or indirectly responsible for it, and it directly affects us. So we try to figure out how we can help. So in the framework, we plan to introduce 4 key points: education, inspiration, connection, and transparency. So we'll educate through a training program, and then we'll inspire the people to create an ecosystem to help others and learn themselves. Then they're connected through a community, and the transparency achieved through an open source platform. Next slide, please. So what we proposed is an open source platform which has verified resources for collating multiple data sets and working on those data sets for multiple applications like Earth observation, and an educational program that teaches the technical and non-technical aspects of it and whatever the problems you're facing and how we can resolve them. Next slide, please. So talking about the open source framework, we have an API-based source which has multiple sources like ESA, NASA, and we introduce a citizen science program in this. We use citizen science AI and model predictive control, which is a good program for decision making. What we basically do is we take data from the satellites and the constellations. This data is more or less processed by various organizations and independent researchers. That data is fed into the main framework, which is then sorted by the AI and the MPC, which makes sure that it is continuously updated. Then it is also given to the citizens to work on it. Like, since we know data science is an important part when we work with data, the data needs to be cleaned and worked upon, and it needs to be implemented. Technically or non-technically, people can help. So this is the system that we devised in the open source front. Next slide, please. Now, the mission that we have is is providing education to people and training people in both the technical and non-technical fronts, and to build an active and participating community. There might be some potential barriers, like the credibility and combination of the data might be an issue, which could be resolved by using trusted resources and statistics and data science to clean the data. Then people generally lack a connection with the problem. They do not realize where the problem is or how they can help. That can be addressed by making sure that we provide the app training, and we can also provide perks and incentives so that people can participate more. Then, to make sure that the system is continuously updated, we'll have an active feedback system, and to prevent rigidity and so that the project can be expanded, there will be modularity and there would obviously be scope of expansion. Next slide, please. Now, this is the framework that we propose. So there's an open source platform to begin with, which is a very user-friendly platform. On coming onto the platform, we choose the track. Now, I'll explain the track. The track is basically, it would be different for different stakeholders. For example, some people are directly affected by all these changes, by the climate change. Suppose we have someone on the coastal areas who are directly living there. They would see those effects much more than someone who is in an inner city and an urban city. So that would affect the kind of action that they can take, and also how it can be technical and non-technical as well. Technical in the sense they can help with open source and developing the tools and the frameworks, working with the data. Non-technical would be just educating themselves, people around them, and taking other steps. So upon assessing that, the material and the data would be assigned to the people. Then they can either train or they can directly take action, which is non-exclusive. They can do both of those together, or however they want to proceed, depending on the experience and learning that they have. And then perks and incentives can be introduced, like certifications and courses, so that people have some more motivation to contribute towards the cause. And essentially, we all bind it up together with spreading the word, which is as important as the training itself. And when they spread the word, it all binds up to the open source platform again, so that it continues in a continuous cycle and helps us making a change. That's all from our side. Thank you.
Thank you so much, Aman. Then I leave to the next working group, and then we take the questions. Thank you.
Hello. Okay, so for this part of the presentation, I'll be talking about the framework that we think is necessary for the security and prevention of illegal activities at sea. So as a subgroup, we believe this is a very important aspect, and this is something that's necessary to protect all the different entities that exist within the sea. So we're going to touch on some of the issues that we identified and also mention some of the solutions that we have. But firstly, it's important to define what is maritime security. So this is the combination of preventative and responsive measures to protect the maritime domain against threats and intentional unlawful activities. So before we go into what some of these threats are, we need to define who defines these regulations and who decides what is unlawful and who defines regulations to tackle these problems. So right now, the biggest authority on this is the United Nations Division for Ocean Affairs, who provide a regulatory framework. This is very detailed and very lengthy framework that tells us exactly on which processes we can take to tackle set situations. But as we can imagine, this is very hard to maintain and implement due to the very remote nature of the sea, really, and also the very international nature of this domain. So as we can imagine, every region around the world will have its own capability and processes to tackle these problems. So it becomes very complicated very quickly. So the objective. So we, as a group, we decided the most important step to achieve maritime security is to improve the maritime domain awareness framework. So this implies the collection, fusion, and dissemination of enormous quantities of data to identify threats early and as distance as possible from shores. So we believe by implementing the MDA properly, we can gather all these different data sources that we have, and through this, solutions will arise for all these different problems that I'll identify in the next slide. So, for example, as you can see from this image, we have loads and loads of different data sources. So, for example, we could combine optical data that we have with maritime patrol aircraft, or we can combine data from the maritime patrol aircraft and people that are on shore. And essentially what this does is it gives us a better picture of the illegal activities that are taking place. So we already have all these data sources available to us. It's really a matter of putting them together so that all the authorities can see what's happening from all these different viewpoints. And yeah, sorry, next slide. So these are some of the issues that we identified that we need to tackle and we believe can be better tackled through the use of the MDA system. So one of the biggest ones is ship oils and debris spillages. As we all know, this is devastating for marine wildlife. This kills animals and just damages the marine ecology in general. And then another issue is humanitarian location and rescue of immigration vessels. So with better satellite imagery and collaboration with onshore police, this can be tackled better. And then another really important one is wildlife conservation. So there's organizations such as Sea Shepherds, which are helping to tackle, to save animals such as whales, which are being hunted down by hunters. And if we had better collaboration, these could work with the local police authorities, and someone could go out and get these people. Another issue is ecotourism. So this is making sure that there's no impact on maritime ecology due to the tourism. And this can be done by monitoring the pollution that's output by these sources. And now for the next points, I'll pass you on to Kim.
Yeah, thank you, Saria. Yeah, the other issues that we also need to tackle are illegal cargo and human trafficking, as well as piracy, and then early detections of tsunamis and ice accumulation on ship route. To strengthen our maritime domain awareness, we are using satellite intervention, which provides us with an integrated solution of implementing different ways of providing data that can increase our awareness at sea, even in the most remote locations. If you take a closer look at the images, or look at the slide, you can actually see our images. The first image is from Capella Space, which uses a method of Earth monitoring images. The second image is a communication link between satellites and ships to provide a stronger sense of security and surveillance. The bottom left image shows satellites using a ship detection algorithm that inspects speed and routes of ships, and the two furthest to the left, as well as on the bottom, uses images to detect ships and oil spillages. Next slide, please. We have created a framework to handle satellite data to strengthen maritime domain awareness in steps. The first step is that the satellite gathers the data such as the ship's type, route, and speed. Then the data is transferred over to an international organization such as the UN, which the organization will then perform an analysis using advanced artificial intelligence or machine learning to produce a rapid analysis and outcome. So first, if the ship made a distress signal or if it was an immigration vessel, there should be a rapid automatic connection made to the local authorities to deploy rescue teams. Alternatively, if marine pollution was detected by AI, such as oil or debris, we need to track and monitor the past and future data to locate the culprits or the people who were responsible, and then assist with cleaning and developing cleaning strategies. However, if we have simply detected a ship's location, the data would then be automatically compared with other data coming from other international registers, such as private fishing companies that, for example, are illegally fishing in West Africa, to determine whether the ships should be allowed there or have trespassed. If the ship is not legally allowed, we continue to track and monitor the ship for any suspicious and illegal activities, and then this data will then be transmitted over to the local authorities for them to act on it as evidence. Thank you.
Thank you so much. That was all of the different groups. Thank you for your presentations. I will bring everybody back to the floor and then we can open for questions. So, we have now, it was actually quite perfect on time. We had spent 20 minutes and that was exactly what we aimed for. So now I'll go to the opening questions. The first question I have here is, how about awareness and avoidance of whale strikes for maritime traffic? Approximately $10 million of damages per year means that this should be considered as well. So the question is how we raise awareness and avoidance of whale strikes for maritime traffic. Anybody want to pick that one?
So I think Zaria gave a part of the answer in his presentation. Well, they talk more about whale trafficking and monitoring that, but for collision with whales, I think yes, it is important to take it into account in the awareness. And as we saw with some of the ESA presentations, that they're able to track as areas with whales migration. So we might also implement that data if we want to trace routes to avoid ships passing in those areas and limiting this risk. But of course, yeah, it's something we have to take into account for sure.
Okay. Would like somebody add something to this, or I go to the next question? Okay, the next question is, how do you make sure that if you are collecting and interpreting data, that it will be done in an independent way?
I think that's a difficult job to achieve. Like, that's sort of a difficult problem, but it can be made sure that people can be appointed from neutral parties to make sure, data science experts. And also, since the frameworks are supposed to be open source, the contributors and enthusiasts could help keeping in check. Like, that's like when people work themselves, they need to make sure that the data is up to the standards. And I think that would be great if the people themselves do it. And yeah, I mean, also also requires a lot of cooperation from everyone involved in the project, all the stakeholders. So yeah, I mean, if anyone has to add anything to it, that's what my thoughts are.
Okay, I think it's the last question we had. So if there are no further questions, I would like to thank all the delegates for their great work these last days, and Mirta for a huge support as a second moderator to the group. And also a big thank you to ESA, who sponsored this working group and has helped also with presentations and moderating. So thank you all, and we look
Thank
forward
you so
to
much, everyone.
Thank you, Mirta and Hannah. Thank you.
Thank
we
you.
look forward to the next presentation.